Hello, welcome to today's lesson on kinetic energy. So we're going to introduce this by talking about the equation for kinetic energy. So as we can see, it's EK equals half mv squared, and we're going to talk about each individual symbol. EK, evidently, is the kinetic energy, and that's always measured in joules. M is the symbol for mass, and that's measured in kilograms. And V is the symbol for speed, and that's measured in meters per second. Now, this equation is, I suppose, an interesting equation because it highlights a thing that we call a square law dependency. This kind of equation pops up quite a few times over the course, and even more so in A level. So it's important to get a grasp of these so that you can use them quickly in the exam environment and understand little tricks about them. So we're going to use the example of a objects travelling at different speeds, but they are the same mass. So in this case, we'll have an object travelling at 5 meters per second and an object travelling at 10 meters per second. So E1 is going to be the energy for the object travelling at 5 meters per second, and obviously this is all algebraically, but we're going to show the effect here. So that's just simply half mv squared. Now E2, which is going to be the symbol for the object travelling at 10 meters per second, we're writing the speed here as 2v, as it's twice the speed of the previous object. Now in a when this is squared, we pull out 4v squared, should I say. Now this 4, you can multiply the whole equation by that, so you get 4 over 2 mv squared, which simplifies to 2mv squared. So once you compare this to the energy of the first one, that's 4 times the energy. So even though the speed only doubled, the energy quadruples. This is a key thing about square law dependency that you need to be aware of. So we're just going to go over a quick question, just so you can put into practice what you've learned in this. So a 70 kilogram person is running at 7 meters per second. What is the kinetic energy of the person? So I'll just give you a few seconds just to have a think about that question. So first thing we want to do, write down the equation, and then we're going to look at all the parameters and see exactly what we've got here. So as we can see, we plug the numbers here, so half 0.5 times 70, because that's a 70 kilogram person. And times 7 squared. In this case, I've just put times 7, obviously the same as 7 squared. And this comes out as 1,715 joules. Second question. A 1,300 kilogram car has a kinetic energy of 65,000 joules. What speed is the car travelling at? Now, this is one, it's still about kinetic energy, but you've just got to have a little trick about rearranging that equation. So, as per usual, we're going to start with the equation, and then we see that we want to rearrange for the speed, which shows that V equals the root of 2 times the kinetic energy over the mass, which, therefore, plug in the numbers, 2 times 65,000 over 1,300 equals 10 meters per second.